So let's go over the unique paths problem. So this is basically where we have m by n grid, and we start at 0, 0. So here's our starting point, and we have a 3 by 7 grid, and our output should be 28. And we can only go either right and down. We can't go up or we can't go left. So we're good on that. So we only go right and down. That's going to be part of our rule. And we're going to go m and m. It's going to be our m by n matrix. And we start at 0, 0. Let's see what constraints we have. So we have 1, which is going to be less than or equal to m and n. So it shouldn't be bigger than 100, but it shouldn't be 100 bigger than 100 by 100 array. So we're good. I think we got a good holding of what we're about to do. So let's plan this out. So what should we do? What should we do? So here, what we're gonna do is, so we have a 3 by 7 grid array right here. We have 3 right here, 7 right down here. Now, the first thing I'm thinking about is how about we just we put some numbers in this array. So what number should we put? So let's put the number 1. We're going to put the 1 as a placeholder. So we're going to put 1s all here. We're going to put 3 rows of 1s. So it's going to be 3 and 7 1s in the grid. So why are we putting 1s? So what we could do is we could use these 1s to get our solution. So what we're going to do is build upon this problem. So we use this 1 as a placeholder. So we're going to ignore this 1. So this will be ignored. So this will be ignored. And what we're going to do is, all we're going to do is this. So we're going to add these two, and then this will be our solution. So add these two, and this will be our solution. 1 plus 2 equals 3. 1 plus 3 equals 4. 1 plus 4 equals 5, and so on, so on. And it works for the bottom as well. So if we go to the bottom, 2 plus 1 is 3. 3 plus 3 is 6. 4 plus 6 is 10, so on, and we got our solution right here, 28. So all we're doing is a bunch of small problems. We're just doing a bunch of small problems as we're getting the answer, and just getting to our answer, which is going to be the last element in our array. So let's say you don't believe me. Let's say you say, oh, this is not, how does this work? Like, why are you putting 1s here? And why are you like doing all of this? So let me prove it to you. So here is a 2 by 2 array. And we have a 2 by 2 array. We could only go down right here. These are the only ways we can go down here. So let's place the arrows on them. So we're going to put 1 arrow right here. We're going to put 1 arrow right here. That's the only way we can get there. We'll do the same way for the other side as well. And as you can see, this area has 2 arrows. And this has 1, and this has 1. There's only one way of going here. And there's 2 ways of reaching this square. So we got 2 ways and 1 way right here. And then we just mark them as 1, 1, and 2. And that's why we would put like 1s here, because we only visit these 1 time. And the others we visit multiple times. So let's continue. Let's do it in a bigger array. So here we have a 3 by 3. And in this 3 by 3 array, we have 1 goes down, and see 1, 1, and it looks the same as this last one, 1, 1. This visits it 2 times, and we got 6. So the solution for this one is 6. So we have 6 arrows on here, and all we got to do is add 3 plus 3, and we get 6. And you can see like all the destination. If you want to pause the video, you can see how this makes sense. That all the arrows will lead to the last one. So all the arrows lead to the last one. So we're going to have to think it like this. Like all the arrows are leading to the last one. So that's where our solution will be all the arrows in this last box. So basically it would look like this. So we only visit this square one time. We visit this 1 time. We visit this 1 time. Visit here 2 times. We visit here 3 times, and we visit here 6 times. And all we got to do is, if we want to do it mathematically or coding wise, we just have to combine these 2 positions in the grid, and then we get 6. And I think, yeah, we could do this. All we got to do is like do a for loop, because we're handling a grid. So since we have a grid, we're gonna have to generate this grid. So we're gonna have to make a for loop and then add the number from this position and this position. So we have to do this. So it's gonna be I minus 1 j, I minus 1 j. So let me just write this down. So this would be, so let's call this r, and we're gonna say I minus 1 minus 1, and then we're gonna put j, and then we're gonna add r, I, and j minus 1. So it makes sense. Yeah, we're just gonna add those two. Let me just put this to the right because I want to make this readable. Let me just fix that. I'm just gonna rewrite it. We're gonna actually write it in code. So if we think about it, so it should be r, and we're gonna put I. We're gonna put j minus 1. So j minus 1 will be the next element in the column. So this will be j. This will be our j right here. J minus 1. And this will be our I minus 1. So we're going to put that. And then we're going to put r. Then we're going to put I minus 1 and j. We're going to add these two together. And that's where we could get our solution. So this is how we will get our solution. So we'll call this res. All right, awesome. So now we have a blueprint on what we should do. So basically all we gotta write is, so we're gonna generate, we're gonna be using Python for this one. We're gonna generate a list, and it's gonna be for in range m. The reason why we're using in range m is because our m will be the rows. So our m will be our rows. So we'll consider the m as our rows. So here are our m. So our m will be this. And then this will be our n, which will be the columns. And then this will be the rows. So we're going to write that. We're going to generate 3 of these lists. And we're going to use list comprehension for this. And then we're going to do for I in range. We're going to start at 1. And we start at 1 because we're not starting here. We're not starting right over here. Because if we start, we are starting over here, but this does not count as a step because we didn't step into anywhere. We step into this or step into this. Let's assume this is 0 and this is 1 and this is 1. So we can do that. And all we gotta do is put for I in range from 1 to m, and for j in range 1 to n, and rij will equal to ri minus 1 j plus ri j minus 1, and we just return the end of the list. So let me show you that. And it should look something like this. So it should look something. So basically, let's go to that last one right there. It should look like this. So your j minus 1 right here, and your I minus 1, and you just add these two together, and this is the solution right here. So whatever this location will be added by this. It'll be the sum of these two. All right. So let's see if this works. So we're going to submit it. And it works. Let's do some test cases. I just don't want to say it just works. We're going to put write directly. I'm going to put the number, I guess 10. Let's see if it works. And it, 1 minute. Oh yeah, because it's m by n. It says input arguments by n. So let's see if this, let's try to put m by n. So let's use a test, write directly. We're going to say 10 and 3. Oh, so I guess whatever Leetcode from here doesn't work. Yeah, we could just do that. I mean, it works, but it would work for 10 by 3 or 3 by 10. So this is the dynamic programming approach. The next one will be the mathematical approach. So the thing is, we don't need to generate this array. We don't. We could do this mathematically, actually. And using math will just turn this from all of all of m times n to just all of 1, because we're only going to be using numbers. We're not going to be storing anything. So how do we do that mathematically? Well, first what we want to do is so all we got to do, so since we're dealing with the grid and we're dealing with how many times we're going to get to that, we're dealing with combinations. So how many combinations can we make going down here? So this is where we deal with factorials. So we're dealing with factorials. So we're going to be dealing with basically how many combinations we can make. And we got to make sure we don't overcount. So we can't count this. So we're going to have to minus 1 for this one. So how about this? We're going to add this together. We're going to add this 3 and this 7 together. And then we're going to put it as k equals m plus n minus 2. Minus 2 is to prevent us overcounting. So this is the minus 2. So when we're going down here, we're just going to remove this. So we're going to say k is m plus n minus 2. And then what we're going to do is put k factorial, and then put m minus 1 factorial, and n minus 1 factorial. Same thing, the same procedure as last time. This is just to prevent overcounting. So when we do that, we're going to get our solution, because once we do the k factorial, we get the combination of that. We're going to get rid of all the extras, and basically we got our solution. Yeah, so this one is to get rid of the extras. Because if we wanted all of this, we could have just said, I think 7 to the 3rd power or 3 to the 7th power. Well, it would be 3 something, because basically it would be something like this. So we're going to multiply these two instead, because we do have, because we're only going down and we're only going right, we have constraints. So yeah, you have to do that. So what we're going to do in code is basically write k will be, we get math.factorial. Let's assume this is all of n runtime. And we're going to say m plus n minus 2. And we'll do the same thing right here, math.factorial, multiply these two together. And then we're going to use the ceiling. We want to round up. We don't want to round down. So we're going to round up. Make sure that all the numbers are up so you're consistent. And then we got our answer right there. And our space now turns into all of 1. So this is the mathematical way. And yeah, the runtime is better, and memory usage. Yeah, because our runtime is all of n, because this one is all of n squared. So we just reduced that, and we reduced our space. So this is more better. But I encourage you to do the dynamic programming way, because it's more realistic. This is more of a realistic way to approach a problem rather than just using a math formula. Which the math formula logically makes sense, but I highly encourage you to do the dynamic programming way first. So thank you for watching, and let me know if you have any comments.